Okay, in this video we're going to be looking at how to solve a quadratic. First we're going to be given a factor. So if we're told that x plus 3 is a factor, that means that if we put negative 3 into the equation, we'll get 0. So what this looks like is if you've got a linear term, x plus 3 is a factor, then you know that there's a quadratic, which I'm writing out here, which when multiplied by the linear term will give us this cubic. So we have to find out what's a, b, and c. Well, when you multiply a linear term by a quadratic, you're going to get this expansion here. The black part is the cubic term. Then we're going to get the power of 2 terms. Now we'll have the linear terms. There'll be 2 of these. And lastly, we'll get the constant. So by comparing the coefficients of our equation on the right and the one we're given, we can see that the coefficients on the left correspond to the ones on the right. And we can use that to figure out what a, b, and c are. We'll start with a. A has to be the coefficient of x cubed by itself, so that means it's 9. So a is 9. Now we'll move on to the 27, the coefficient of the x squared. That has to be equal to this bit. Now because we know that a is 9, we can work out, so if a is 9, 3 times 9 is 27, that means b has to be equal to 0. So we know b is 0. We'll move on to the linear term. So the coefficient is 64. We've got 3b times x plus cx. Now we know b is 0. So that means that c is 64. Lastly, we have to figure out what k is. We know it's equal to the last term, 3c. So since c is 64, k is 192. So we figured out what k is. And I'm just going to use the a, b, and c values we found before. A is 9, b is 0, c is 64. So my quadratic that I still need to solve is 9x squared plus 64, and this doesn't have any real roots, so we're done. Okay, here's another example. So in the last one we were given one of the solutions, but I'm just guessing what I might have here because I'm not given the solution. So I know that if I made some random quadratic expansion, then I'm going to multiply all out and end up with my last term being a, b, c. So that means the negative 60 bit, if we just ignore everything else, that's a times b times c. So at least one of these has to be a factor of negative 60. Otherwise, it's very difficult to solve by hand. So you'll always be given one where one of them at least is a factor. So here's all my factors of negative 60. If one of them is plus, the other one's minus because it's a negative number. So up to 3 of these will be factors. At least one of them will be, and there could be 2 imaginary ones. We'll come to that later. So I'm just going to test them out. So it's a bit of a long process, but if I try 1, it didn't work. I'm going to try plug 2 in, see if that gives me a remainder of 0, which would be a factor. So if I plug 2 in, I get, nope, that doesn't work. I'll try negative 2, see if negative 2 works. Closer, it doesn't work still. I'll try 4, because 4 looks like it might be, based on what I just saw, 4 looks like it might work. Yep, okay, so if we add those and minus those, yep, that's 0. So 4 is a factor. We know 4 is a factor. X equals 4, so one of our brackets can be x minus 4. So if we use that, if you use x minus 4 is a factor of this cubic, then x minus 4 times our quadratic that we don't know like before, and we're going to do the same thing. We're going to compare coefficients. So if I just expand this out, x times bx, right, so there's the expansion of the linear term which we found out, the quadratic that we still need to find. Now we're going to compare coefficients. So I can see from looking at the x cubed term, a has to equal 2. Looking at the last term, negative 4c has to equal negative 60, so c is equal to 15. Now comparing the x squared coefficients, we know they have to equal 5. Since I know what a is, I can work out that b has to equal 13. Now I'll do the same thing for the linear terms. Negative 4b plus c has to equal negative 37. I don't really need to do this one, but just to prove that it's all works to us, then by rearranging this equation, I can find c is equal to 15. Already found that, but just proving that it worked. So now I know my a, b, c values. I'll just plug them in. So a is 2, b is 13, c is 15, and here's my one that I guessed before. I guessed it. So now I'm just going to have to solve this one, this red quadratic, to find the other two roots. So I can factorize it, but this is a level 2 skill, so I can factorize it. That'd be fine. I could use the quadratic formula to do it, or I could just use my calculator because you don't get a mark for it. It's only a level 2 skill. So by just factorizing it here, you can see that it's my other two answers. So by solving that, I'm going to get x is 4, which I guessed. From this one, x is equal to negative 3 over 2, and x is equal to negative 5. That's my three factors. So here's another one. Like I said, normally you'll be given one of the factors because guessing it is a time-consuming process and it's not particularly interesting. So if we're given another one, here's just another example to show that it isn't as long and complicated as it seemed before. So once again, take my one I'm given, multiply it by a quadratic, start to expand out. And you'll see that we don't even need to do the full expansion even, but you can see that when you expand out, the last term is going to be negative 16, so that tells me c is negative 8. A is 3 because it's 5ax squared, x cubed. So we just need to look for the term that gives us the 31. So we're not even going to do the whole thing. We're just going to multiply that bit out. That tells us that b is equal to 5. So here's my cubic again. And I've managed to find out what b is. So now I just need to expand this out to get the linear term. And that will tell me my k has to equal negative 30. So now I just need to solve that. I found my missing coefficient. I just need to solve if it's possible. Sometimes it won't be. Sometimes it won't give us real roots. This one will work. This one will work. So 8, 1 plus that. So x is going to equal those two values or the one we were given. And that's it, 3 roots.